Yes, good evening everyone. Please turn on your video before we start the class. Okay. So guys, today we are going to continue with the circles topic which we have started in the last class, right? Now, we have done up to some sums over here. Yeah, we'll be doing some sums from your exercise. Okay. Now what you have over here, two circles of radii, this and this, intersect at 2 points and the distance between their centers is 4. Find the length of the common chord they are asking. Okay, let us solve this question. Yeah, what you have, two circles of radii 5 intersect at 2 points. Okay, let us consider the two circles as this. Okay, let us consider these are the two circles. Okay, and they are intersecting at 2 points. They will intersect like this at 2 points, and at a distance and the distance between the center is 4 centimeter. Okay, one radius is of 5 centimeter and the other radius is of 3 centimeter. The radius of this is 5 and the radius of this is 3. So the two circles will intersect like this, or there will be another way, because the distance between them they are saying that is 4. Now this is not possible because this length is already 5, right? So this is not possible. So the circles are not intersecting like this. The circles are intersecting like this. Means it is it is like this. Got it? The center of the circle is over here. The center of this smaller circle is over here, and the distance between them is this. Are you getting it? Yeah. If this is the chord of the circle, wait, it should be even more inside. Wait. Yeah. Now, if this is the chord of the circle, okay, the center of this circle, suppose it's outside, it's inside over here. Now, the radius of this circle, you know that if I draw a line over here like this, okay, I know that if I draw a line over here like this from this center to touching over here, and if I name it, let's say this is O, this is A, B, C, D, and E. Fine. I have given the namings like this. You can also name it as like this also, O, O dash, because these both are centers, no, that's why. O, O dash, then A, B, and C. And this point of intersection, that is D. Fine. Now, two circles of radii 5 centimeter. I know that OC is equal to 5, that radius of the bigger circle. Yeah, and 3 centimeter, the radius of the smaller circle. The radius of the smaller circle, this is also 1 point. Okay, I'll draw one line over here. This is also a point. Let's say this has point E. Okay, what I know, O dash E is how much? 3 centimeters. Okay, intersect at 2 points and a distance between the centers is 4. What do you know? That is O O dash is how much? 4. Are you getting it? O O dash is 4. Find the length of the common chord. This common chord length they are asking what it will be. Okay. Are you getting it? Everyone has understood the diagram properly? Yeah.
Yes, sir.
Okay. Fine. Now,
Yes, sir.
now, what we need is what is required? The length of the common chord. So AB is required. Okay. Now, how you'll find the value of AB? To find the value of AB, we know what is OC. We know that what is O dash E, and we know what is O O dash, right? To find the value of AB, so what we will have to do? Let us say this we know OA, we know it, right? O dash we know it. OD we know it? No. We know as O dash E. Let us consider this O dash D. Let O dash D is equals to X. Let us consider this distance as X. Okay? That distance as X. So OD will be how much? OD will be how much? Because we know what is O dash, that is 4 and 4 plus X. So OD will be 4 plus X. Yes or no? Yeah.
Yes.
We know that OA is 5. Yeah. We know that OA is 5. So what will be AD? We can find in terms of X using Pythagoras. Yeah.
Yes.
This square plus this square and this AD we can find in terms of X. Also in triangle. Wait. Just yeah. So what we can do over here now in this. Okay. In triangle. In triangle ODA. What I can say, OA square will be equal to OD square plus AD square. Yeah. OA is how much? 5. OD is how much? 4 plus X plus AD. We do not know it. So let's keep this as unknown. AD square. So this will be 25 will be equal to 16 plus 8x plus x square plus AD square. Yeah. Or you can also keep it like this only. Let's keep it like this only. Wait. Let's keep the equation like this also only. Now again, if I take again this figure and if I take another triangle now, in triangle, in triangle O dash DA, okay, in triangle O dash, this O dash DA, I know that AO dash is how much? This is again the radius of the smaller circle. The radius of the smaller circle is how much? 3 centimeter.
3.
So I can say this distance as 3. Again, I have that in triangle O dash DA, O dash A square is equals to O dash D square plus AD square. Again from this O dash A is how much? 3 square is equals to O dash D, which is X, we have already assumed, plus AD square. So what do you get? This is 9 minus X square is equals to AD square. Yeah. We have also got AD square over here also. Oh, wait. I also got AD square over here. Yeah. So AD square over here was 25 minus 4 plus X square. Yes or no? So I can equate what if I say one, this is 1, this is 2, equating 1 and 2. Equating 1 and 2. So what I get, 9 minus X square is equals to 25 minus 4 plus X the whole square. Yeah. So 9 minus X square is equals to 25 minus 4 plus X, that is 16 plus 8X plus X square. So what you get, 9 minus X square is equals to 25 minus 16 minus 8x minus x square. This minus x square and minus x square will get cancelled. 9 is equals to 25 minus 16 is how much? 9 minus 8x. Yeah. So 9 minus, oh, it's coming as 0.
Sir, how minus x minus x cancelled?
Minus x square and minus x square can get cancelled, no? They both are on the
But
opposite sides of the equal.
it's okay, okay.
They are on the opposite sides of the equal, no? So if I take this on this side, it will be plus x square. That's why. Yeah.
Okay, sir.
We are getting it as 0 only. This 9 and 9 will get cancelled. Again, it will, wait, there is some mistake. In triangle OD, O dash DA, O dash A square, O dash D, and AD. Okay. And the other triangle which I have taken is ODA. In this, OO dash is how much? 4, and then plus X, and this OA is 5, plus AD square. Yeah, everything is right. So this should be 25 minus 4 plus X square. Wait, 16 plus 8X plus X square.
Sir,
Yeah.
sir, we can put x value in first equation also.
Yeah, that can also, no, we cannot put because that X is inside the bracket, no? That X value is inside the bracket. Just a moment. AD square equals this, and then AD square equals this. Wait, 25 minus 6 is 9. This is 9 only left. Is there anything wrong? Two circles of radii 5 and 3 intersect at 2 points. Fine. Fine, wait, I'll do this sum again. Let's draw two circles first. These are the two circles. And if this is the center, and this is the center of this, and if this is the point of chords intersection, and if I draw a line from here to here, okay, this will be the radius of the bigger circle, this will be the radius of the smaller circle. Okay, fine, now it is fine. Let's say if this is O, this will be O dash. Okay, after that, if I say this is A, this is B, and this is C. Fine. Now what all things I know in this? I know is OA is how much? 5, the radius of the bigger circle. Okay. After that, I know the radius of the smaller circle, that is O dash A is how much? 3 centimeter. This is 5 centimeter. And the distance between their centers, that is OO dash, is how much? 4 centimeter. Okay, all this thing I know. If I consider O dash C is equals to X, okay, I'm considering O dash C is equals to X. Now what I will do, in triangle OAC, okay, in triangle OAC, what I know, OA square will be equal to OC square plus AC square. OA is how much? 5 square OC. OC will be OO dash plus O dash C, and O dash C is X, and OO dash is 4. So that is 4 plus X whole square plus AC, which I don't know. Okay, so I can write AC square equals 5 square minus 4 plus X whole square. Fine, I can write this. After that, again I'll take this figure. Yeah. Now, in triangle O dash CA, in triangle O dash CA, again, what I know, that is O dash A whole square is equals to O dash C whole square plus AC square. I know that O dash A is the radius of my smaller circle. The radius of the smaller circle is 3 square is equals to O dash C, that is X square plus AC, that is not known. O dash C, yeah. So AC square will be equal to 3 square minus X square. Yeah. So over here AC square is this and AC square is this. What I got in the last sum, AC square was
Sir, OC should be like the distance that is 4 centimeter, right?
OC. No, it is OO dash because that is the distance between the two centers. O dash C will be, we have taken O dash C as X, no?
So we can solve by Pythagoras, should, right? theorem, like
Wait, wait.
OA is equal to.
Okay. If this is 3, this is 4, and this is 5, okay, the center has to go beyond that. That is the reason. That's why it is not coming. See, what is the reason over here? If this is 4, this is 5, and this is 4, this is 3. If this is 3, this is 4, and this is 5, it has to be a right angle. It has to be what? It has to be a right angle, no? Because it's a Pythagoras triplets. If this is 3, this is 4, and this is 5, it has to be a Pythagorean triplet. That's why it is not coming. So what we have to do? We have to draw the circle on the chord only. It means the center of the circle should be on the chord. This OC is this, O dash is 4, and this is 5. Okay, wait. We'll do it again. This is your bigger
So,
circle. Yeah.
sir, I solved it. I got the answer as 6 centimeter.
Two, two circles of radii 5 and 3. Means the radius of this circle is 5. This is 5. This is 3. And intersect 2 points and the distance between their centers is 4. That means this is 4. Got it? And it has to be a right angle only. Because it's not possible that the center will be misplaced. It has to be a right angle. Got it? Then find the length of the common chord. Length of the common chord will be simply, it will be 6. Since find the length of the common chord. See, this can be a right angle only. Only then it can be a right angle. Got it? Now we can write, since the lengths 3 centimeter, 4 centimeter, and 5 centimeter are are Pythagoras triplet. You can write they are Pythagoras triplet. Then what we can say? Actually, the x which was coming 0, that was also right. Are you getting it? The answer which we was getting the value of x as 0, that is actually right. Because that distance is 0, no? The distance has to be 0. That's why the value of x is coming as 0. Because this and this point should coincide. So you can write, we can continue over here only. What we are getting, 9 minus 9 is equals to minus 8x. And ultimately we are getting x equals 0. Got it? We are getting x equals 0. So therefore what we can say? Therefore, point, which one? Point O dash and D coincides. Point O dash and D are coincident. They are coincident. That means they are one above the other. Therefore, you can draw a new diagram. The new diagram will be like this. Got it? After getting it that the 2 points are coincident, so that then the diagram will be like this. Understood? And then we can say, therefore, length of common chord. Length of common chord will be 3 plus 3. That is this. 3 plus 3. That gives you 6 centimeter. Is that clear? Yeah?
Yes, sir.
Yeah? Why it is coincident? I hope you have understood. Yeah, since we are getting the value of x as 0, so that means both the points are same. That's why they are coincident. And now if it is coincident, we will draw a new diagram. So therefore this will be 4, this will be 5, and this will be 3. And then if this is 3, this will also be 3. Got it? Fine. Now let's go to the next question. Now what they have given, if two equal chords of a circle intersect within the circle, prove that the segment of one chord are equal to the corresponding segment of the other chord. That means if you take the circle like this, okay, and over here if two chord if two equal chords, okay, let's draw two equal chords. The length of both the chords are equal and consider this as the center of the circle. If two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to the corresponding segments of the other chord. That means this segment is equals to this and this segment is equals to this. That's what we need to prove. Got it? Now how we will prove? We are given, what is given in this? If this is AB and this is CD, the length of both the chords are equal. That is AB is equals to CD. That's what that is given. Okay, and what we need to prove? To prove is, if this is A B C D E F, let's say G, then to prove is AG is equals to GD and CG is equals to GB. This is what we need to prove. Okay, now how we can prove this? To prove this, we'll have to do some construction. Okay, there will be some construction required. What we have to do? Draw this line. Okay, after that, draw a perpendicular bisector. Draw this line. After that, draw a perpendicular bisector to it, and over here also. Okay, what do you have to do? Join OG. The construction is join OG and then draw perpendicular to chords, to both the chords, to both the chords from center. Okay, now once we have drawn this, what we can do? Now we'll write the proof, how the two distances will be equal. Right, these are perpendiculars. So what you can take in triangle, this is ABCD, let's say this is PQ. Okay, in triangle OPG and triangle OQG. Okay, in triangle OPG and OQG. I can say OP is equals to OQ. What is the reason?
Sir, they are equal because P and Q are the points, and those points are directly joined
And
to the center, so it is equal.
the reason is equal chords are at equal distance from the center. We have done this theorem last time. Equal chords, if there are two chords which are equal, then the two chords will be at equal distance from the center. Equal chords at equal distance are at equal distance from the center. Got it? They will be at equal distance from the center. That's why OP will be equal to OQ. After that, the other thing which you have is OG is equals to OG. What is the reason? Common. And the next thing which you have is angle OPG is equals to angle OQG. What is the reason? Each 90 degree.
Each.
Yeah, each 90 degree. Fine. If each are 90 degree, then what I will do? Then what I can say? That the two triangles are congruent. Therefore, triangle, wait, triangle OPG is congruent to triangle OQG. Yeah. Once it is congruent, then what I can say? PG is equals to QG. Why? Bicepticity. Also, these two triangles are congruent by which test?
SAS.
SAS. No. See, there are two sides, OP equals OG, OP and OG, right? OP is equals to this, and then what you have, OG is equals to OG, right? This and this angle. This angle is not coming in between both the sides, no? So it is not SAS. What it is then?
ASS.
It is right angle hypotenuse side test, RHS.
RHS.
It is right angle triangle, no? So it is by RHS test, by RHS test of congruency, by RHS test of congruency. Okay. That is clear. Now I can say PG is equals to QG by CPCT. Yeah. Now I know that AB is equals to CD. This was given. Yeah. This was given. So half of AB will be equal to half of CD. Now half of AB will be what? AP. And half of CD will be what? QD. Yeah. That will be QD. AP is equals to QD. Now if I say this is my 3 and this is my 4, adding 3 and 4, adding 3 and 4. So what you get? Yeah. Now after adding 3 and 4, this is 3 and this is 4, right? If I add both of them, AP plus PG will be equal to what? QG plus QD. Now what will be AP plus PG? That will be AG, and QG plus QD is how much? GD. So hence proved. 1. There are two proofs which you need to prove. The first thing is proved. Now again, we know that AB is equals to CD, which was given, which is given, right? Let's say this equation as phi. So subtracting with phi, subtracting with subtracting with phi, what you get? AB minus AG is equals to CD minus GD. So AB minus AC is how much? AB, oh no, AB minus AG. No, how it will be? AP plus PG will be, yeah, it will be
AB
equals to,
minus GB, I think.
yeah, wait. AB minus, yeah, it's right. AB minus yeah, it should be AG. AB minus AG and CD minus GD, yeah. So now AB minus AG will be how much? GB, and CD minus GD. CD minus GD will be how much? CG. So hence proved the second one also. Clear? Yeah?
Yes, sir.
Yeah? Okay, fine. The next one. So these two sums have been done. If two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angle with the chords. Okay, let us prove the third one also. If two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection of the center makes equal angle okay, it is the actually the same thing only. It is the same question. The same diagram we'll have to use. I will be explaining you in short for this question. It is the same diagram. For this question also you have to take the same diagram. What all things you have? If two equal chords, the two chords are equal, okay, intersect within the circle, they are intersecting within the circle. Prove that the line joining the point of intersection, prove that the line joining the point of intersection to the center, to the center, this line, yeah, makes equal angles with the chord. This angle is equal to this angle. The same thing you have to prove that the two triangles are congruent, and again that these two angles are equal. That's it. Understood? Yeah? Clear?
Yes.
Please raise your hands if it is clear. Now the next question. If the line intersect two concentric circles with center O at AB and CD, prove that AB is equals to CD. This we have done in the previous lecture. We had this question, right? Yeah, this AB is equals to CD. This it is the same question over here, Vijan. If two lines if a line intersects two concentric circles with center O at A, B, C, and D, prove that AB is equals to CD. Yeah. Now over here, three girls Reshma are playing a game by standing on a circle of radius. Reshma throws a ball. Fine. Let's solve this question. What they have given? Three girls, Reshma, Salma, and Mandeep, are playing a game by standing on a circle of radius 5 meter drawn in a park. Reshma throws a ball to Salma and Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meter, what is the distance between Reshma and Mandeep? Fine, they are standing on a circle. Fine. If I draw a circle like this, okay. Three girls, Reshma, Salma, and Mandeep, are playing a game by standing on a circle of radius 5 meter. The radius of this circle is 5 meter. Is 5 meter. Reshma throws a ball to and between them Salma and Mandeep is 6 meter each. Okay, the distance between them is 6 meter only. So if this is the first one, this will be the second one, and this will be the third one. Okay, let's say this is Reshma, Salma, and Mandeep. Okay, Reshma throws a ball to Salma, and Salma to Mandeep, and Mandeep to Reshma. Okay, they are throwing balls like this. Reshma to Sandeep, Sandeep is giving to Mandeep, sorry, Salma, and then he is giving to Reshma again. Fine. The cycle of passing the ball, passing a ball was is like this. Now what they have given? If the distance between Reshma and Salma and Mandeep is 6 meter each, that means if this is 6 and this is also 6, then what is the distance between Reshma and Mandeep? So this is what they are asking. How you will solve? Yeah. Now to solve this, we'll draw some more lines. If I say this is my center, I will join these 2 points. I will also join this point. Okay, what I need given is what? RS equals 6 meter and SM equals 6 meter. To find is, you have to find is RM is the question. That is the distance between them. Clear? Did you understood the question?
Yes.
Yeah. Please
Yes,
try
sir.
solving and get the value of RM. You please try. If you don't get it, I will be solving, but you please try it on your own first. 5 minutes.
There is RM perpendicular bisector.
RM. Yeah, it will be because it's a chord, no? Yeah, if this is a chord and this RS, this distance and this distance are equal, right? So if this distance and this distance is equal, what all things you have? The radius of the circle is 5. So this is 5, this is also 5. And they have given this as 6, this also as 6. So yes, it will be perpendicular. But wait. It will not be perpendicular. We cannot finalize that it will be perpendicular. Yeah? We cannot finally say that it will be perpendicular. We only know this. It is not given that it is perpendicular. We also did not know it. We have to find what is the value of Rm.
Sir, this distance between that S and center would be also fine, no?
Center and R would be?
S point.
Yeah, it would be 5. Yeah, that would be 5. Yeah. So what I can do to solve is, okay, fine. Okay. Now, over here, if this is O, if I draw a perpendicular over here like this, if I draw perpendicular bisectors over here, I can draw this. Yeah, I can draw this. No, these are perpendiculars. If these are perpendicular bisector, I have drawn them by construction. If this is 5, I know that this complete is 6. So this will be how much? 3. This distance will be 3. Yes or no? Yeah.
Yes.
Okay.
Yes, sir.
If I say ORSM and let's say this is point A and this is point B. So in triangle OAR, in triangle OAR, what I get, that is in triangle OAR, if I want to find this OA, it will be OR square will be equal to OA square plus OA square plus RA square, and OR is 5 square equals OA is 3 square plus RA the whole square. Wait, OA is not known and RA is 3 square. So your OA square will be equal to 5 square minus 3 square. So OA square will be equal to 25 minus 9. So OA square will be equal to 16, and therefore the value of OA will be 4. So we got that this height is how much? 4. Okay, we got this. Yeah, one more thing. We know that if this quadrilateral ORSM will be a kite, because this side and this side is equal and this side and this side is equal. What happens in a kite? What happens in a kite if there is any kite like this? If there is any kite, what happens with the diagonals of the kite?
They are perpendicular bisector.
They are not bisector, they are only perpendicular to each other. They are what? They are perpendicular to each other. So since this is 5, this is 5, this is 6, this is 6, so what I can see, these are perpendicular. With the help of kite property, I can say that OS is perpendicular to RM. Yeah. So I will also write that property over here first. Yeah. What I can say, that in quadrilateral ORSM, I know that OR is equals to OM and RS is equals to SM. So what I can say, therefore quadrilateral ORSM is a kite. Since it's a kite, therefore OS is perpendicular to RM. Fine. Now if it is perpendicular, if this is perpendicular, so this will also be perpendicular. So I can also, yeah, this is known. I know that this is this. I can find. Yeah, we can find now. Now, now let us take this figure again over here. What I got, OS is perpendicular to RM. Now, in triangle ORS, in triangle ORS, area of triangle ORS is equals to what? Half into base into height I can write. Yeah, half into base into height is equals to half into, I can consider the RS as base and OA as height. Yes or no? So RS is
Yes.
6 and height is 4. I know this. So 2 3s are 3 4s are 12. 12 square units is the area, or it's a centimeter. Meter. 12 square meter, you can say. 12 square meter, I can say. Okay. Again, the same thing I will use. Area of triangle ORS can also be written as, area of triangle ORS can also be written as half into base into height. Again the same thing, but I can, this time I will change the base. The base can also be OS and the height can be, let's name it over here RSTABC, let's say C. So OS into RC, can I write this? Because this is also perpendicular, no?
Yes.
Yeah. So area of triangle ORS is how much? 12 is equals to 1 by 2 into OS. What is the value of OS? That is 5. And what is the value of RC? That is unknown. Got it? So if I take this 5 and 2 on that side, it will be 12 into 2 upon 5 is equals to RC. So the value of RC is 24 by 5. So the value of RC will be 5 4s are 20.5 40, then 5 8s are. So the value of RC is 8. And you need to find what is the value of RM. The value of RM will be, since it is perpendicular, since it's a perpendicular, these are equal, no? These two sides will be equal. So RM means this OC is a perpendicular bisector of OM, right? Sorry, RM. So the value of RM will be twice of RC. That is twice of 4.8. So that gives you 9.6 meter. So the distance between, what were their name? The distance between Reshma and Mandip is 9.6 square units, 9.6 meters. Understood, everyone? Do anyone has any doubt in any particular step? You can ask, please. Yeah, everyone over here. Is that clear?
Yes,
Yes,
sir.
sir.
How many of you have understood clearly? Please raise your hands. Sixth question. A circular park of radius 20 meter is situated in a colony. Three boys, Ankur, Saeed, and David, are sitting at equal distances on its boundary, each having a toy telephone in his hand to talk to each other. Find the length of the string of each phone. Fine. What we will do, there is a circle involved in it. So first let's draw a circle. Now what they are seeing, a circular park of radius 20 meter. The radius of this circle is 20 meter. Let's say this is 20 meter. Fine. This is what is given. Three boys, Ankur, Saeed, and David, are sitting at equal distance on its boundary, each having a toy telephone in his hand to talk to each other. Now, these three boys are sitting on the circle and they are at equal distance. Yeah, all of them are at equal distance. See, this is equal to this and this is equal to this, but this will also be equal. Then it will have to be an equilateral triangle, no? Because the distance between all of them are equal.
Yes,
Yeah. So to make an equilateral triangle, it will be like this. It will occupy the whole triangle, that means the three friends are sitting like this, where it is forming an equilateral triangle. Got it? It is forming an equilateral triangle. Let's say this is Ankur, this is Saeed, and this is David. At equal distances on its boundaries, each having a toy phone in his hands to talk to each other. Find the length of the strings of each phone. The length of the strings will be what? What will be the length of the strings? If they are sitting at the three corners, the length of the string will be the distance between them, no? Yeah, that will be the distance between them. That means you need to find AD or DC, DS or AS. That's what you need to find. So how you'll find it now? I know that this is 20. Okay. Fine. How I can solve? I know that if I draw a line through the centroid and equilateral triangle, it will cut this side in a perpendicular way. Yes or no? In an equilateral triangle, if I draw an altitude through the centroid, it will be perpendicular to the base. We know it by using a equilateral triangle properties. Okay, so this will be perpendicular. What I know that this is 20. I don't know any other thing. There is also a property in an equilateral triangle that the centroid of the equilateral triangle is in the ratio of 2 is to 1. Means I know that the radius is 2, but if this is the centroid, then the ratio of this side, if this is AS and let's say this is C and this is G, then CG is to GD. What will be CG is to GD? It will be 1 is to 2. This is by centroid of the triangle, since it's the centroid of an equilateral triangle. So this distance upon this distance will be 1 upon 2. We already know it. So if this is 20, so what I know, CG is to GD. So CG upon 20 is equals to 1 up, sorry, this is 1 and this is 2. Yeah, 1 upon 2. So the value of CG will be how much? 20 upon 2, which gives me 10. So this is 10. So now what I get? If this is 10, the value of CG is how much? 10. Okay. I need to find what is the length of I got that this is uh, uh this is 60 degree, but the trigonometry has not been taught to you, no? So we cannot use trigonometry in this. Um, this is 10, this is 20, 30. The total length of the altitude is 30. Okay, and yeah, I can get this. If I draw a line over here, if I draw a line over here, I know that this is 20. So can I get AC by using Pythagoras? Yes or no? I can get
Yes.
AC using Pythagoras. So using AC, let's find what is Pythagoras. So in triangle ACG, angle C is 90 degree. So therefore, AG square is equals to AC square plus CG square. AG is how much? 20. So 20 square is equals to AC, which I don't know, plus CG, that is 10 square. So what I get? AC square equals 20 square minus 10 square, which gives you 400 minus 100, which gives you 300. That is what your AC square. So the value of AC will be how much? Root of 300. That gives you how much? Root of 300, no? So that will be root of 3 into 100. So that is 10 root 3. So the value of AC is 10 root 3. If the value of AC is 10 root 3, what will be the value of AS? That is twice of that. So the value of AS will be twice of AC. So that is 2 into 10 root 3, which gives me 20 root 3. Got it? The answer will be 20 root 3. So the length of the each string of each phone will be 20 root 3. The same thing, because that will be the distance. All the sides are equal. So if you find any one distance, that will be equal to all the sides. Yeah, is this clear?
Yes, sir.
Sure.
Sir, can you teach one more time?
Okay, fine. See over here. See, this is a circle, and they have said that this all these three students or whatever friends, they are sitting at equal distance, right? So it has to be an equilateral triangle, that this distance is equal to this is equal to this, right? After that, they have given that the radius of the circle is 20. Okay, this was also given. Okay, we know that this center will be the centroid of this equilateral triangle. Yeah, the circumcenter and the centroid of the equilateral triangle will be same, because it's an equilateral triangle. That's why it's not a scalene triangle, not even an isosceles. It's a equilateral, because that's why the centroid and the incenter and the circumcenter will be at the centroid only. Okay, all the points will be same. So now for this, what we can say, yeah, if this was given 20, if I draw an altitude, I know that the centroid means, if I draw if this is an equilateral triangle and this is the centroid. Okay, what I know, this are in the ratio of 2 is to 1. Using that, I can write that is CG is to GD is 1 upon 2. Got it? Yeah. So using that, I got the value of CG is 10. So once CG is 10, I know that this will also be 20. Using Pythagoras, I found the value of AC. That is how much? 10 root 3. Once you get the value of AC, I can get what is the value of AS, because that AC is the perpendicular bisector of the chord. This is perpendicularly bisected. So this length is will be the twice of this. So that is AS will be the length of the required string. And that's what we have found over here. Got it? Yeah?
Yes.
Okay.
Yes, sir.
Now the next. Yeah, this is what the theorem is. What they have given, the angle subtended by an arc at the center is double the angle subtended by at any point on the remaining part of the circle. Now, what is the meaning of this theorem? First, I will explain you that. Suppose this is your circle. Okay, this is what? The circle. The angle subtended by an arc at the center. Suppose if this is your arc, this is what? The length of the arc, and this is the center. Okay. Now, what will be the angle subtended by the arc at the center? Will be this. Yeah. This will be the angle subtended by the arc at the center. The angle subtended by an arc at the center is double the angle subtended by at any point on the remaining part of the circle. That means if I draw two lines on the remaining part of the circle, then what will happen? If I draw, means angle subtended by this circle, it will be this. Okay, angle subtended by the same arc on the circle, and this is angle subtended at the center. So what they are saying, that this angle will be twice of this angle. What they are saying? Are you getting it? What they are saying to prove? The angle subtended by the arc at the center is twice as the angle subtended by the arc at any point on the circle. Got it? The question is understood. Please reply in the chat box, or you can raise your hands. Did you understood the theorem, what it states exactly?
Yes.
Yeah. Now you please think on it. How we can prove that this angle will be equal to double of this angle? What can be the process of doing it? Please start thinking on it. If you don't get it, I will be explaining you. But you please start thinking how we can prove.
Sir, can you repeat which angle double?
See, if this angle is x, this will be 2x. We need to prove this.
Okay.
See over here, what you have to do. Suppose if this is your O, this is your A, B, and this is your C. Okay. Now to do this, what I have to do is I will be drawing this line. First, I'll write what is the given and what we have to prove in it. What is given? The angle subtended by an arc at the center is double the angle subtended by at any point on the remaining part of the circle. Nothing is given. Both the angles are at the same arc. That's what is given, right? So what you have to prove in this? To prove is angle AOB is twice of angle ACB. Yeah, angle AOB will be twice of angle ACB. Fine. To prove it, we'll write the proof. See, to prove it, we'll draw a line over here. I will draw this line. Okay. Now, in triangle OCB, in triangle OCB, what I know that OC is equals to OB. What is the reason? They are radius of same circle.
Yes.
Yeah, radius of same circle. So I can say OC is equals to OB. Now that means triangle OCB is an isosceles triangle. Yeah. Therefore, I can
Yes.
say angle OCB is equals to angle OBC. They are isosceles triangles. Why? They are isosceles triangles. That's why the opposite angles will also be equal. Yeah. If I extend this line up to the arc, okay, and this is D. Okay. Now angle OCB is equals to angle OBC, right? This I. Got it. Why? Because the two triangles are the triangle is isosceles. That's why. Right? Okay. So let angle OCB is equals to. So what was given over here? I know that OCB is equals to OBC. I have considered that both of them as X. Okay. Now I know that angle in triangle OCB, what I know, angle OCB plus angle OBC plus angle COB is equals to 180 degree. Since both of them are same, so I can write 2x plus angle COB equals 180 degree minus 2x. Sorry, 180 degree. Then therefore angle COB will be 180 degree minus 2x. Yeah, it will be 180 minus 2x angle COB. Now again, now COD are collinear. COD are what? Collinear. These 3 points are collinear. So can I say angle COB plus angle BOD equals 180 degree? What is the reason? Linear pair.
Linear pair.
They are linear pair. Angle COB is 180 minus 2x plus angle BOD equals 180 degree. This 180 goes 180 minus 2x goes on that side. Angle BOD equals 180 degree minus 180 plus 2x. So finally I get angle BOD equals 2x. Are you getting it? Angle BOD means that is if this is x, I'm getting this angle as 2x. Okay. Similarly, this triangle AOC will in triangle AOC, AO and OC is equal. Therefore, these two angles are also equal. If I say this is y, this will also be y. Yeah. And after that, after solving it, I'll get that this is 2y. So angle ACB is how much? Angle ACB is equals to x plus y, and angle AOB is equals to what? 2x plus 2y. Are you getting it? 2x plus 2y. So
Yes.
angle AOB is equals to 2 of x plus y, but angle x plus y is ACB. So therefore I get angle AOB is equals to twice of angle ACB. Understood? And you can write hence proved over here.
Yes.
Yeah. How we can prove that this angle will be half of this angle, or we can say this angle is double of this angle for any circle. Got it? For any circle means even if the lines are drawn over here, suppose even if the lines are drawn over here, even if the line is drawn over here, still it is the same. That is, this angle will be double of this angle. It applies for all the angles on this circle. Now what this theorem states? The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Did you understood what the theorem is trying to state? How many of you
Yes.
have understood what the theorem is trying to state? Please raise your hands. The next is just the theorem. You don't need to prove it. The same thing can be proved this. Now what they have given, you can just note it down. Angle in the same segment of a circle are equal. Now why they are equal? Because see, if I draw a circle, any circle like this, If I draw any circle, and if this is the center of the circle, okay, and what they are saying, if this is any angle and this is also any angle, okay, what you have to prove in it, this angle and this angle both are equal. Angle in same segment, in same segment means this is the segment, okay, angle in same segment. If they are in the same segment, then what? The two angles will be equal. Means even if I draw an angle over here like this, okay, even if I draw this angle will also be equal. All these three will be equal. Got it? Now what will be the proof of this? The proof for this is very easy. That is, if I draw a line through the center, it is based on the previous proof. If I say, if this is A, B, O, C, D, if I write this, what I have, angle AOB, or you can say angle ACB, is half of angle AOB. Why? Angle at center or angle at the circle, or you can say like this also. Angle AOB is equals to twice of angle ACB. Why? Angle at center is twice the angle at any point on the circle. What is the reason? You have to write that statement. Angle, the previous theorem. Angle at center is twice the angle subtended by the same segment at center is twice the angle subtended at any point on the circle. Similarly, I can say that angle AOB is equals to twice of angle ADB. The same reason. So from 1 and 2, I can equate both of them because the LHS is same. Therefore, twice of angle ACB is equals to twice of angle ADB. And after cancellation, what I get? Angle ACB is equals to angle ADB. And therefore, angle at angle in the same segment of a circle are always equal. This is the reason. Understood?
Yes.
Is that clear? Yeah? Okay, then we'll continue this in the next class. Okay? Chalo then, bye bye.
Okay, sir.
Yeah,
Bye, sir. Thank you.
yeah, bye. Thank you.